Oh God,
Somehow.
2020. Yeah. Oh God,
Somehow.
2020. Yeah. Yeah. Oh God, yeah, so we have
2020.
the normal stuff. If you're not already in the Slack group, there's slack.bostongamedev.com. That's where we post the events like this, and we have like the Bit Show hangout and things like that. So definitely join that if you're not there already. Speaking of Bit Show, tomorrow night, 7 p.m. we have the Bit Show with Gwen Frey from Kine. She'll be talking about that game. It's coming to Steam soon, and yeah, should be good. Anything else?
I guess we'd invite people to write in the Twitch Slack if they have announcements, and we can
Yeah.
Can say them. Yeah.
Are we starting? Okay, great. Fantastic. Yeah. Well, thank you for having me, first of all. I really appreciate being here. I've been to Boston once, I think. It was like PAX 2013 or something like that. There was a blizzard. It was horrible. But the city is great. I'm Abdullah Hamed. I'm a program manager at .NET, and I focus on game development communities like this. And I'm here to give you an introduction to C# for beginners. And specifically, the second half of the presentation will focus on C# for Unity. Let's have the slides rolling here. Let's see. I need to put the Zoom things in its right place. All right. So here's some assumptions that I'm going to come into this presentation with. I'm going to assume that you don't understand code. Either you see it and you try to avoid it, or you read it and it just looks like gibberish to you. You might have experience with the Unity editor. You know what prefabs are, what components are, what is a hierarchy view, what is the inspector window, stuff like that. And also that you have a little bit of background in asset creation. You know, you either used Photoshop before or something like that. I'm not going to depend heavily on that, but that's just in the background there. And I'm also going to assume that you know basic arithmetic, you know what an add symbol is, and multiplication and division and greater than and less than and equal and stuff like that. And the scope today of my talk is going to be, or the content of this presentation is going to be a little small talk about what is .NET and C# and why program if you're a Unity artist. Then I'm going to talk about basics of programming, talk about things that are like building blocks of programming, like variables, methods, and branching. Then I'm going to dive deeper into object-oriented programming, and I'm going to explain what classes are and what are access levels. These are things that start popping up with object-oriented programming. And then we're going to have a small 15-minute break. And then I'm going to start talking more specifically about Unity and how the concepts we just talked about will apply to Unity. I'm also going to talk about Visual Studio and its role in developing for Unity, as well as talking about debugging as a concept and how to use it within Unity. So let's get started. And then we're going to have a Q&A. Also, we can also have a Q&A during the break. And that will be a good way to kind of segue into cover all the questions about basics of programming and object-oriented programming before we get into Unity-specific topics. So what is .NET? The marketing spiel is a developer platform for building all your apps, and it's free, cross-platform, and open source. It allows you to build all of these different types of applications for the web, mobile, desktop, game development, machine learning, cloud, Internet of Things, all the things pretty much. But how can .NET really do that? .NET is a set of programming languages C#, F#, and Visual Basic. It also contains a couple of libraries, and you can think about libraries as toolboxes made for specific languages. There are different tools in these toolboxes, and it enables you to do things with that specific language. Think about it as smaller programs. And then there are runtimes, and runtimes enable these languages and libraries and programs to run on different machines. So let me explain that a little bit more. If a program done with C#, F#, or Visual Basic, we can imagine that program being kind of like an Android. I just started watching TNG during the pandemic, and it's been wonderful. So I'm very obsessed with data. So let's imagine data as programming is done using C#. But data needs to ride a car if he needs to kind of traverse or ride on different roads. And you can think about, and so that data can kind of traverse different terrains, right? So we can think of machines like different terrains, deserts or mountains, and operating systems as roads. And then a runtime, you can think about it as a Subaru Crosstrek. You can take it on a street, but you can also take it off-road. And that's the power of the .NET runtimes. Before the idea of runtimes even started, developers used to have to take into consideration the operating system and the actual physical machine. And whenever a machine changed or an OS changed, they needed to rewrite the application pretty much. But that changed with runtimes because you can just program once and deploy to different operating systems and processors. So .NET has different runtimes. It has the .NET Framework runtime, and that was what classically used to just be called .NET, right? The .NET runtime. And it only works on Windows. There's a .NET Core runtime, and this is the new open source .NET runtime, and it runs on Windows, Mac OS, and Linux. And then there is Mono, which used to be an open source interpretation of .NET. And it used to be developed by a company called Xamarin that was acquired by Microsoft. And it enabled C# applications to run on Windows, Mac OS, Linux, iOS, Android, consoles, microwaves, all the things. I'm not sure about microwaves really. But since the acquisition of Xamarin by Microsoft, Mono became .NET. All of these three runtimes are .NET runtimes. So how does Unity use .NET? The runtime, the Mono runtime that Unity uses, turns the C# code that you write and turns it into an actual executable code. And that happens every time you click on the play button in Unity. And that turns the game into an executable, and you can actually interact with it inside of the editor. But it also happens when you actually build. At the end of the process, when you actually build the game, it uses the runtime to turn the game into an executable. And that what enables you really to code once and run everywhere. You can run your games everywhere you want, VR experiences, simulations, anything that Unity supports. So why program with Unity? The cool thing for artists to know about programming for Unity is that you can control the assets dynamically. You can switch textures in the middle of the game. If a certain event happened, you can just switch textures. And if you have different shaders, you can actually apply different shaders to the same texture dynamically while running the game. And this makes it so that you don't have to use as much memory and you have as many textures. You can really reuse textures and just apply things programmatically to it. You can change text in the UI. You don't have to create new buttons or anything like that. And change the layout of the UI, control the transform of different objects, and so many more features that it can do. And all of that while the game is running. And that's what's so cool about it. So what are programs to begin with? Programs are a set of instructions that computers can understand. And all of what computer science has been doing since the beginning of computer science was try to make languages that the machines can understand, but also close to how humans interact with each other. And that's the purpose of programming languages, is to make interaction with machines as close as possible to how humans interact. And something to know also, usually with programs, especially programs like C#, they're sequential. So every line of code executes in a sequence from top to bottom. All right, I guess we're ready to learn the first concept in programming, which is variables and operations. So what are variables? Variables are containers of data. Told you I really love Star Trek. They're containers of data, and they have a type. For example, data is a humanoid android. That's the type. I'm glad you laughed. Let's see. No, that's great. I love it. It's the first time I ever got feedback since I've been giving this talk online. I didn't know the joke was good or not. Okay, good. I just didn't know the joke landed or not till today. Okay, so with variables, we got things called primitive types. These are types that are usually by default, they're available in most languages, like integers, 1, 2, 3, just whole numbers, floats, 1.2, 0.12, and in Unity, we put a little f after the number just to make sure that Unity understand that it's a float. And then there's Booleans. Booleans have two states, either true or false, 0 or 1. We also have strings, which we put between different parentheses, or just not different, just parentheses. And these are kind of primitive types. There are other ones like characters and different things, but these are kind of basic ones that we will be using later. Also, all the types that are inside of Unity that you can use, like game object, rigid body, all of the different components inside of Unity are also kind of like variables, but we can dive into those a little bit later. And when you first, with any good relationship, I guess, creating boundaries and expectations is very important. So before we start programming and using variables, we have to declare them and kind of tell the runtime that we want to use this thing, for example, here called speed, that is of type integer. And the way that we write this is first we write the type, which is int, that tells the runtime that we want to use an integer, and then space speed, and that's the name of that variable now. It's called speed, and it's of a type integer. It's C# is case sensitive, so speed with a capital S is not the same as speed with a lowercase s. And yeah, and the semicolon at the end pretty much just instructs the runtime that this is the end of the command. It's kind of like saying over on walkie-talkie, you know, just like this is the end, I'm done. Let's start a new operation. And how do we assign now values to this variable, right? Like we want speed to be equal to 100. So we use the equal sign here. And we can just easily say speed equals to 100. And the value with the assignment equal sign, anything on the right side will be assigned to anything on the left side. So if there is another value in speed, it will be rewritten here. So if speed was equal to 10 before, and then we did this, then speed will be equal to 100, and we lost the value of 10. And you can actually combine assignment and initialization or declaration first. You can say int speed equals to 100. And this way you can just do one operation. Well, not one operation. Internally, it separates it into different operations. But just for you as a programmer, you can just do everything in one line like this. So yeah, so there's another type, I guess, that is called var. And it's not really a type. What we're telling, when you say var speed equals 10, what we're telling the runtime is that, how about you infer and you figure out what 10 is, and then set the value of speed to be that. So here, the runtime will figure out that 10 is an integer. So it will set the type of speed to integer. And this is, you'll see this a lot. It's not the best way to do things. Once you start getting into optimizing your code and all of that, you might not want to use var. But if you're just hacking and you just want to get things done pretty quickly and you don't want to deal with types, var is a good keyword to know. So now that we have these variables, how do we do operations on them? We got to know what the equal sign does. It's assignment. You can also add different variables to each other, divide them, multiply them, all of these different things. And usually when you do one of these operations to variables, the result will be of the same type. So if you add two integers, the result will be an integer. If you add two strings, the result will be a string. If you multiply two strings, you'll get a string. But there are other type of operations that are called logical operations. And what these operations take is what they will give you, will result in, is either a true or false Boolean. And that's kind of what they're used for. For example, is equal, if you put equal next to each other, that's not really an assignment. What's happening here is that we're checking the value of whatever on the right side of that operation to the value of the right side of the operation. And if they are equal to each other, then the whole operation will result in a true value. And exclamation mark equal means not equal. So if they are not equal, then it will actually return true. Also, there's other logical operations that it can use. For example, if you put and next to each other, then that is considered an and operation. And what that takes is two different true or false statements. And if they're both true, then and of those two true operations will be true. But if one of them is false, then the whole thing will be false. The OR operation is, as you can imagine, if one of the two sides is true, then the whole statement will be true. So let's give a little bit of a test here, a small little one. I want you all to note this down, write it down, put it somewhere, and try to figure out what will be the value of X, Y, Z, and A. Write it down? Good. I guess people can write it in the chat or something like that, and so people can scroll up to it again. All right, so let's do a little demo about variables. It's going to be a short little demo. Let's, where am I? There you go. So here is a really cool tool that I'm going to link to at the end of the presentation. There's going to be a PDF that I'm going to link to with all the different resources that I use. Over here in the .NET Microsoft documentation, there's a really cool tool where you can just write code up here and actually get the output down here in the browser. So it's a cool way to kind of figure out how to use C# and .NET. They also have like a lot, like really very detailed tutorials here too, if you want to do it by yourself. So let's do something very simple here. So here I have, let's see, let me actually maximize this. I think that'll be best for everybody. Great. Is it clear for everybody on the stream? People can see the text, or should I make it bigger?
Looks good.
Looks good?
Looks
Okay,
good.
good.
Yeah.
All right. So we're starting here with integer x. We're declaring that we want to use an integer called x, and we're assigning 1 to it. And then we're creating another variable of type integer called y, and we're assigning 5 to it. This little operation, you don't need to worry yourself with it, but what this does is that if you put a variable or any value here, it will just print it at the bottom here. That's all you need to know for now. So now we're giving it a 10 here, putting between these two braces here. And if we press run, it will just print 1 because x is equal to 1. If we put y, it will create, it'll just print 5. But what if we did, let's say 1 or x plus y, and we actually assign that to x. What this does is that it calculates everything on the right side. So x plus y is equal to 6. And then it will rewrite the value after that of x to be 6. And if we print x here, then it should print 6. So that's how operations happen. Pretty simple. So how about if we try something different? Let's do an operation on a string. So we're creating a string called g, and we set it to be equal to good, and p equal to yum. And then we are, let me just delete that here, and we're just printing g plus p. You can do operations inside, like inside of different functions, and I'm going to talk about a little bit later. But now, if I ran this, it'll just concatenate the two strings or squish them together. So that's how operations happen. Pretty simple, huh? Let's go back to our presentation. So another concept that is really cool to learn is how to do branching. Because you want your application to go to do different things based on different things. So here is the first statement that you really need to know is the if statement. If takes a true or false statement inside of the brackets, and it will or parentheses brackets, yes, and it will do a thing if it's true. And if you add else and then open up a squiggly brackets, it will do this other thing if it was false. So x minus 3, if x was equal to 1, then this whole statement is true, then it will do a thing. If x was equal to 4, then it will do the other thing. Simple? I think it is. Another one to learn is while. Well, same idea. It takes a true or false statement, and it will keep doing the thing inside the squiggly brackets until the value of the condition here, x minus 3, x less than 3, is equal to false. And of course, you always have to worry about x never being over 3. And that's what is called an infinite loop sometimes. If you ever heard that term, this is where it is. Sometimes you see it in really bad movies when they just say things like, we're in an infinite loop, and they have no idea what they're talking about. But this is what an infinite loop is. This is when this thing happens. So let's do another demo. Same where was I? Here's the thing. Let's delete all of that. And where am I? Okay, here's the demo. I'm going to take you step by step into what I wrote here, and then we're going to step into the loop and run it and see if the result is as expected. So declared an integer called x, and it's equal to 1, and we print what's inside of x. Then here we're saying, do everything inside these squiggly brackets, like the bigger ones here. See how they got highlighted? Do everything here until x is no longer less than 3. What we do here is we have x equals to x plus 1, so we just add 1 to the operation every time that we go into a loop. And then we print x again. And then we check here, after we add 1 to it, is it under 3? If it's less than 3, then we're going to print out, bummer, still in the loop. But if it was equal to 3 or over 3, then print, oh boy, I'm about to be free, and let loose from this loop. And then out of the while loop, I'm printing, yay, I'm free from the loop. So let's run this. There you go. The first one got printed here when we just assigned x to 1. Then we went to the loop once and we added 1 to it. So now x is equal to 2. And this is where we printed 2. And then we checked. Is 2 less than 3? Yes, it is. So we printed, bummer, still in the loop. There you go. That's the third line. And then we went back into the loop. We never really printed, oh boy, I'm about to be free. Not yet. We went back into the loop. We added 1 to x, and that made x equal to 3. And we printed x, so now we got 3. And here we're checking, is 3 less than 3? No, it's not. It's equal to it. So it's not going to print what's in here. Bummer, still in the loop. It actually will print, oh boy, I'm about to be free. Because the next operation after printing this will be to check in the while loop here, is 3 less than 3? And that, as we just found out, that's false. So we print, oh boy, about to be free, and then check again if x is less than 3, and that's false. So it never executes anything inside of here because it's false, and instead it prints whatever comes next, which is yay, free from the loop, and we can see that printed down here. So that's how you branch out your application. There's multiple different loops too. There's like a for loop that you can do, or for each, but that's an advanced topic. You can research that yourself and learn more about how to use those different features. So let's go back to the presentation. Next thing we're going to talk about is methods or functions. You might hear people calling it functions. In C, it used to be called functions, but in programming languages like C# or Java, we call them methods. You might hear me say functions, and that's totally acceptable because I said so. So what are methods? Methods are a group of operations. Pretty much you're grabbing a whole bunch of different operations like we did before, and you're putting a bow over it and creating a macro, if you're familiar with like Photoshop macros. And it takes a parameter. You can pass it different numbers, different values, different classes, variables, and it will return you can return a value or a variable or whatever you want, right? Like whatever type you want it to return. For example, if you can look at addition as a method, you're giving it 2 numbers and it's giving back to you a number or a string in case if you're doing the operation on strings. And here, yeah, you can return a variable type. So as with all good relationships, got to declare your boundaries and how you're going to use these methods. So you just got to tell the runtime what is the method that you're going to be using before you use it. So the way to do it is to start with the return type. For example, if we want to create a method that just adds two integers together, the result is usually an integer because math. You start with a return type, which is integer, and then the name, which is add here. It's very customary within when programming to give names to variables in lowercase and for methods to have the first letter be capital, and then you open up brace and then have integer, or have the different types of parameters inside of it now. So you can have, we're having here integer x and integer y. And what we're doing inside here is doing x plus y and make that equal to x. I mean, you can have z, you can have any other variable here really, but I'm just reusing the variable that we're using here because I don't need to create a new one. And then here I say return x. And what this does now, it's like adding x and y, assigning it to x, and then returning the value of x. Whatever comes after the return statement here needs to be the same type as the return type that we added at the beginning of the declaration here. So integer, x better be an integer, or else this won't work. It will give you an error. And when we're using the function now, all you do is just you say the name of the function, open up these braces, and put in the two values that you want to pass. So now if you're adding 3 and 5 here, x, when you're executing the code inside the method, x will be equal to 3 and y will be equal to 5. And the result, of course, z will be equal to 8 after executing this method, or this like whole line. So let's do another demo. Oops. Enter focus mode. There you go. Let's delete all of that we created. And let's create a method. So the cool thing about methods, remember when I said that programming is sequential? Method definitions exist out of that scope. It's like in a third dimension. It doesn't exist in the same dimension as the sequential kind of code. So if we added, for example, created the same addition function that I created before, I called it integers, the return type, the name is add. It takes an integer called L and an integer called T. We're adding L to T and then assigning it to L, and then we're returning L. When we're executing this code, it really just goes to line 1, line 2, and then it stops. Because this is just a definition. This is not executable code. Does that make sense? I hope it does. So how can we use this now? Let's create another variable called z, integer z equals, and then you just create add, like just say add, and pass x and y to it separated by commas. Yeah, you separate, whoops, I always press Control S and try to save a web page, and that doesn't work. I keep doing it every time I get this presentation. It's really funny. Just such a muscle memory thing. So yeah, with parameters, you always just put a comma between them. That's what separates different parameters. So now we're adding x and y, and then we are assigning it to z. But I want to print z. Let's see what value of z is. Is it going to be equal to 6 or not? Are we doing things right or not? Press run, and the output is 6. So the code is going sequentially, but once it hits add, it jumps all the way here. execute what's inside the method and then goes back again. So it doesn't really exist in the sequence. The last sequential thing that it executes is line 6 here. So this is what methods are. Congratulations. Method Man will be very proud of you.
I actually had a quick question for you.
Go for it.
If it's okay before we continue. I do hope everyone can hear me this time. I think I got it right. My audio source was incorrect earlier. Apparently, I wasn't even audible. The add method, what is the benefit of actually assigning the addition to one of the original variables and then returning that, rather than just saying returning x plus y or l plus t or whatever?
Mm-hmm. Okay, yeah, that makes sense. Let's see. This is something that I was going to talk about a little bit later, but every time you create a different variable, instantiate a variable, it takes up room within the memory of RAM, right? And when you assign a number to it, because you don't want to forget what is all of these variables, int x and y and z, hold a space within memory. And if you're going to be more memory conscious, then it's a lot easier to not create a new one, but instead just reuse what we have. So that's one benefit to doing this. There's another benefit that I think is a little bit more advanced for this talk, which is passing by value and passing by passing something to or scoping, I should say, for variables. For example, L and T are not accessible outside of the method. But everything outside of the method here that in the main program are accessible inside of the method. So I can say, actually, like X, and that won't give me an error at all, because I'm accessing something that got declared outside of it. But if I went inside of here and say print L, the main program here outside of the method doesn't understand what is L. L is inside of add. So that's a different scope. That's a little bit more advanced topic. But yeah, I hope that answered your question.
Mm-hmm. We can have more conversation about that later, but I didn't want to derail the conversation too much. But I thought it was an interesting recommendation.
Yeah. I mean, it's just it's just to be. I guess I just got used to being like very memory conscious and not like declare variables that I'm not going to use or just going to use them once and throw them away. Might as well just use what I have.
But if you just return the two added together, does that implicitly?
Sure, that's actually a really good. That's a really great way to do it, actually. Yeah, just return and the two added together, and that's it, because they result in an integer, and it's the same type as whatever's up here. So this works.
Okay.
Cool. All right, so let's talk about object-oriented programming. This is a way for programmers or computer scientists. They try to find a way to make programming languages similar to how we interact with each other as humans. To us, everything is an object. Other people are not other people, but everything that we interact with, like this cup of water, the cup is an object, and water is an object, and everything around us are objects. And we make sense of the world that way, of different objects interacting with each other. And they also have a feature where you can inherit from different objects. For example, there is a chair, and the chair usually has legs or a leg and a seat. But there's different types of seats or different types of chairs, stools, office chairs, and whatnot. But they're all chairs at the end. So kind of like if you're familiar with like 3D modeling, so it's kind of like kinematics, where if you change the properties of a chair, then you change the properties of all chairs. They all inherit from the same kind of base. But yeah, but the way in programming, objects are described by methods and variables, the same way that, those are the concept that we just talked about. You can think of specs as variables, and features and things that these objects are capable of, and describe them with methods. So let's think of a chair, right? Let's describe a chair in terms of variables and methods. We can say a chair has how many numbers of legs, like how many number of legs, and that could be described with an integer, right? There is no half legs usually in chairs. So we can describe the how many legs a chair has by a variable, an integer. And then we can use a Boolean to describe, does it have back support? Does it have like a headrest or something like that, either true or false? But then, there are some chairs that spin, right? Like they pivot around like office chairs or something like that. And what if you wanted them to execute the spin by certain degrees? You can create a method called spin, and you pass it a certain number of degrees and tell it to spin. So that's kind of how you describe objects within object-oriented programming, with a set of variables and methods. So how do you declare the classes before you use them? Well, how do you declare objects, I should say? You declare them with something called a class. They're pretty much blueprints for objects. And like I mentioned before, with the chair kind of example, a class can inherit from another class. An office chair can inherit from a chair, or what we call a base class. For example, a car inherits from vehicle. And with this type of interaction between different objects that are just abstract and they don't really know each other, they're not, every object is defined independently. It makes it so that we needed something called access levels to describe who has access to the different variables and the different methods inside of these objects. And there's keywords within object-oriented programming that describe the different levels of access. There's public. Public allows everybody to look into a class or an object. I'm using class and object interchangeably here, but class is just the definition, but object is what is created from the definition. So with different members of this object, you can set things to either public, protected, or private. So with public, every other object can have access to either that object or different variables inside of that object, or access to different methods inside of that object. Protected makes it so that only children or other objects that inherit from that object can access that thing. For example, we mentioned car and vehicle earlier. If vehicle has a protected speed variable, then that can only be accessed by a car or a motorcycle or any other object that inherits from vehicle. But if a chair comes in and interacted with a car and wanted to know its speed and it was set to protected, then that will not happen. And also you can set things to private, where it makes it so that only that object can access itself and access its variables and methods inside of them. So that's access levels. And the way that we use access levels is by adding it, like, for example, in methods, we just put it in front of the return type. So if you remember the add function or method that we just created, I just add public in front of it. And that will set it so that any other object can access this method. And even if you create a variable, you can do the same thing. Just create put public in front of the declaration of that variable. So let's think about a car class. How does it look like? Let's do a little exercise. So we got variables that describe what is a car, right? It has different dimensions, X, Y, and Z. It has a max speed, acceleration value, how many people can occupy the car, and how many doors. So these kind of describe the car. But also, there are different methods, different things, actions that a car can do. A car can accelerate, can reverse, can unlock doors, can lock doors. And these are different actions that a car can take. What if we wanted to do a Tesla class? A Tesla is a car, so I don't need to define all the things that I defined earlier there. I can just inherit from car. But I do need variables like battery capacity that is not available in a car. Or I can create different methods like charging, for example, give it some like certain voltage or something like that, and that will charge the battery. Or an autopilot. If you want to start the autopilot and have the Tesla actually do that action, then we need a method for it. So that's kind of how you can think about objects and classes and how to inherit from different, how a class can inherit from another class. Also, one of the things that you can do is okay, so now that we created the class, how about we create an object from the class? And you can think about it as you can say, you can describe a cup of water, but I actually want a cup of water now in front of me and put it in memory, in RAM. The way to do that is by just creating the same way that we created all the different variables earlier, right? We created public, Tesla, and then the name of the Tesla here. We can treat the class names now as variables. A class is a type now. So if you go back and look into how they programmed integer or how they programmed floats or any of these basic or primitive types, they pretty much created classes for those. So we're creating here a variable called Tesla, but it's still just a variable. We're just describing a Tesla. It's empty. It's not really filled with an actual Tesla. The way that you actually fill it with an actual thing, you put it on top of your desk, it's in memory, you can use it, is by using the new operator. And the way that you do it is just use new, use the variable first, and then assign it a new Tesla. And the way you use the new operator is write new, and then write the name of the class itself, and then parentheses afterwards. And what that will do is it will create a thing in memory that is described as a class, like the Tesla. It will create a Tesla inside of memory and assign it to Tesla. And of course, you can do both of these things, the instantiation and assignment, all in one line, like we did with variables before. And the way that we access different members in there, because we know that Tesla has different variables and it has different methods. How do you use these different variables and methods is by using a dot notation. After you type down the name of your object that you created, in this case it's Tesla with a lowercase t, and then press dot. When you press dot, you can put any member of that object afterwards, and you can access it if it was public. Well, it depends on the access level, right? Here is where access levels take place, or they actually have effect. So here I'm assigning 10 to the max speed variable inside of the Tesla object. And here I'm locking all the doors. I'm actually using the lock doors method inside of the Tesla object by using the dot notation. So let's do a small little demo again to show how classes work. So let's see here. So let's create a car. The way that we start writing classes is exactly like how you would declare a variable, right? You start with the access level. We want this class to be public and accessible by other objects. And then we want it to be a class. And then we want to call the class car. That's just the name of the class. And then we open up squiggly brackets. And everything inside of here will be a member of that class. So here we created a couple of public variables for dimension, max speed, acceleration, seats, doors, etc. And then we created empty methods for accelerate that takes paddle pressure, for example. Reverse, same thing, takes paddle pressure, open door, lock doors. And that is our Tesla class. Sorry, these are our car class. And now, what if I wanted to create a Tesla class? So we do it again. We write public access level class and then the name of the class. Usually we capitalize the name of classes just like we do with methods. And then we put parentheses, not parentheses, a colon, and then the name of the class that Tesla will inherit from. So here we want Tesla, and we want Tesla to be a car. So we put colon car. And then here we add all the extra variables that we wanted. We wanted battery capacity, and we also wanted it to charge if we pass it, volts in integer form. And here, if you notice, we can actually just we can access max speed. It's not giving us an error. Max speed is not defined inside of Tesla. It's actually defined within car. So anything that's inside of car is actually accessible within the Tesla class. And because we set things to public, it can be accessible to anything that inherits from it. But also, even if we set it to protected, Tesla will be able to access that variable or method. So yeah, so that's how you create classes within C#. I'm putting everything in one file, and that does work, but it's very it's something that you'll see everywhere, is that everybody puts a different class in a different C# file instead of having them all in one document. It's just better for readability. It's better for, it will just make the lives of yourself too, rereading your code and finding things a lot easier to do it that way. So what if we wanted the human to own a Tesla now? So we created a public class called human. Let's capitalize that. And then by the way, I'm putting void here. If you haven't noticed, I didn't talk about that yet. Void just means nothing. So instead of void, usually we would put a return type. We want this method to return something. But if we don't want it to return anything, we can put void. So creating another function or method called unlockDoor, it returns void. And what it takes is a Tesla. And then a Tesla called T. But then what we're doing is that we're telling Tesla to charge by 45 volts, because that's kind of what we assigned it as. But we want the human to actually own a Tesla now. How can we do that? We can say public Tesla called Tesla. We want that equal to be new Tesla. Whoops. Control save right away. So now when we're using new Tesla, what that is doing is actually filling up this variable that is called Tesla with an actual Tesla inside of memory, so that we're ready to use it. If you try to use Tesla right away, then it will, if we wanted to use Tesla right away, then it will tell you, hey, there's nothing in memory called Tesla. It's empty. There's just an empty shell of a Tesla. So here, now that we created a Tesla, I can say Tesla. We have dot. And if you're inside of an IDE like Visual Studio, or this is actually a version of Visual Studio running in the browser. If you press dot, it will give you all the different members of that specific function. So we can say charge, whoops, then open for, and it will tell us it will take integers, and we press 45. So that's how you access control save all the time. So this is how you access different members and use different methods inside of different objects and access them from different objects. I hope that makes sense. And I think that concludes our demo for classes. Is there any questions? All right, maybe we can move on to a little quiz. Remember the different Booleans that we created earlier? How about you copy this down, and what do you want them to do with them, by the way?
Well, I mean, I think we could just say, can you let us know if what will be the result of each of those expressions?
Yeah. Do you want them to send them to you, put them in the chat, or what do you want
could put them into chat. If you put them sort of in a line, comma separated, then you could say that, Alice, Bob, Charlie, whatever you want it to be. But I guess in this case, these will be of type Boolean. So.
Sure. All right. And this actually concludes our first part of the presentation. Okay. And we can have Q&A right now for 15 minutes, maybe.
Someone asked if you could explain getters and setters.
Well, I don't want to confuse people right now with getters and setters. I think it's a more advanced topic for beginners at this point. But it's just a way to do extra operations and extra checks to make sure your other objects are accessing variables or methods in the correct way, or I should say variables. I don't have an answer that is like a pretty answer right now, but because I really don't want to confuse people in general and get into that. But it's a way of in object-oriented programming, there are ways to make sure that people have the right permissions to access something and that the computer doesn't freeze or freak out if you're trying to assign variables or get variables from different objects without permission, or if it's empty or something like that, to just create extra security.
We had
another question that.
Carry on,
go
Elliot.
ahead, Chris.
No, you carry on, please.
A ways back, someone had a question. How do you break out of an infinite loop? What happens when you're in an infinite loop?
I mean, that's. If people knew how to do that, they're all sci-fi movies just break down. They don't make sense. But you just make sure. You have to make sure that there are checks that you put in there. For example, like if you can put an if statement, if this is the 1,000,000th time I'm inside of a loop, something's wrong. and just break out, right? Like you can, there's different ways of doing this and just checking to make sure that you are changing the value of that. The value of the true or false statement will eventually change. Yeah.
Indeed, yes. Now, I did flippantly mention that I used to call myself the queen of the infinite loop in the past because I'm one of those, I want to wait until some condition is true before I break out of this while loop, and I've often failed to intercept that condition. It just happened to all of us at the time. As Peter says, you could just stop the programming, stop running the program. Sure, you could, but sometimes it doesn't work that way.
Stops itself.
Yeah, sometimes it will stop your entire machine and you'll have to hard reset because you could be doing quite a lot in that while loop and you could be generating lots of objects and those objects could be multiplying infinitely and you could end up with showers of physical objects infinitely raining down on your scene. So I don't recommend using while loops without knowing that you're going to get out of them alive.
And sometimes the program is running inside of your friend Android's head and you don't want to turn them off. Like
no. I wonder if anyone actually ever tried that, trying to get data into a infinite loop. That might be a way to bypass and shut him down.
I don't know. I just watched it recently. So
false. And then see if he... Do we have any more questions, guys? We had a couple of correct answers to the quiz already, I noticed, so that's good.
Nice.
Got you all thinking. We had a couple of good suggestions. I quite like them. We were talking about Teslas, and we were talking about the different. When we were creating a new Tesla, the difference in capitalization meant it was a little less clear that which was the new object and which was the class. And so that raised a cool idea of you could have different models of Tesla that you could instantiate as different types of inheriting from a base Tesla, or you could name the instance of that class as something more like my Tesla or whatever you call your car these days.
I'm gonna write those notes down so that the next time I give this presentation, it'll be much more clear.
There were also some good suggestions about chairs, but I forget what they were. So Peter has a very good question about C# and variables. Do they have to start with a lowercase?
They don't have to. I mean, you can do whatever, like you can name variables whatever you want. It's just every company that you work for might have a different, or team might have a different style guide where you have to adhere to it. But I feel like in most places that you're going to be at, most of the code that you're going to see online, you're going to see that names of methods and classes are going to be capitalized. The first letter will be capitalized, and variables and just variables are going to be lowercase. Sorry. I think in Unity, if you're doing something that is accessible by the editor, you also put an underscore before the name. I've seen people do that, and I'm not sure if that's like a common thing.
I think people do that.
There were like 3 ways that you can make something visible in the editor. If you have a private object and you don't want it to be visible anywhere else, sometimes they'll use an underscore to make it like a private member variable that you don't want to have visible outside of the scope of that class. By default, anything that you declare as a public field in Unity, like say public int cars equals 5, cars will immediately appear in the editor, and if it was lowercase c for any reason, it will appear with a capital in the editor because the editor likes to show it with a capital letter.
I'm going to talk about that in a bit. Too.
So that there's fun there, but that's something to be wary of. If you've got a lowercase object that you make public in Unity, it will appear in the editor with a capital letter. But there's lots of other ways too, but that's for another day. I'll let you carry on with that one.
There's little quirks here and there.
Oh yes,
Unity and C#. Yeah, because usually in C#, if you're programming in C# purely, not within the context of Unity, there are There's a lot. The structure is just very different, and that is something that I want to give a different presentation actually for, is .NET for Unity developers, or .NET for or Unity for .NET developers, and just show the differences between both. For example, there is no editor in if you're doing Xamarin or ASP.NET for websites, or doing a desktop application with .NET. But these concepts that we talked about today, not just applicable to C#, by the way, it's applicable to Python, applicable to Java, applicable to C++, even though C++ is a little bit more complex with about memory management and whatnot, but the same concepts are there. Variables, instantiation, and assignment, and methods, functions, and classes. These are applicable to most programming languages out there.
Eli asked for a bit of a clarification. So to make a class, and then he writes access level, name of class, object. Whereas I think we actually want to say access level class, name of the class, right? So
access level, type, and then the name of the class.
Right. So that might be the source of confusion here in a way, because the capital T Tesla is the type, which is also a way of saying a class.
Yeah, I can change this to T to make it a lot easier for folks.
Yeah. So in this case, it's the verbology which goes alongside creating an instance of an object. And what is the difference between a type and a class, which people will hear also?
It's the same thing, really. Like when you create a class, it's creating a type that you can create objects out of. So like a class is more of a blueprint or a class is a blueprint of a type, and you use that blueprint to actually produce something that's an object afterwards, if that makes sense.
Oh, that's good.
There was a question about multiple levels of inheritance, whereas a Tesla inherits from car and car inherits from transportation. Does that mean that Tesla inherits from transportation?
No, it doesn't go backwards. It goes one way. So it's like having a parent and children, right?
But essentially,
it's like having.
It's a little hard to. Yeah, the transportation was the grandparent in that instance.
Oh, yeah, okay.
Yeah, sorry.
Yeah, I mean all of them inherit from each other. So if transportation and let's say Tesla inherits from car inherits from vehicle inherits from transportation. That means that anything that's in transportation will be accessible to Tesla if it was either protected or public. If it was private, we can't.
That's good. Okay. Do we have any more questions from the audience? We had another correct answer, so that was great. No, I think we might be done with questions. No. Is this being posted somewhere? Yes, this will be available on our Twitch site for, I believe the default is 2 weeks after this presentation is finished. So you'll have a couple of weeks to catch up and watch it again. We are also recording the talk, and we are still hoping to put these talks on YouTube. I have all the recordings of all of our talks since the start of lockdown, so I'm still hoping to put those all on YouTube when we get some time. So yes, thank you. I think, Abdullah, do you want to carry on? I think we've reached a pause in the questions for now.
Sure. I did tell people 15 minutes, so maybe somebody left, and we'll come back in 4 minutes. Should we wait? Or do you want to keep going? let's wait for 2.
For 2 minutes. Can you explain protected? That's a really good question.
It's just accessible to its children. That's it. No outside, like no other objects outside of an object. The object and its children can access the protected member.
So how about with that? We go with the 3 hierarchy of vehicle, car, Tesla. What would you describe as something that would be called a protected method on, say, a car? On the vehicle. No, hang on a second. Yeah, let's do it on the car.
All right, sure. I mean, we can set all of the, I mean, we don't want some outside person to change the max speed of a Tesla, for example. We don't want people to access that. That is something that we want it to be protected and only be accessible to, we don't want a human to change what is the value, max speed of a Tesla or a car. So we set that as protected. But we want the Tesla to kind of access the max speed of itself. So we set the max speed in car or vehicle, and then that makes it as protected, and that makes it accessible to any other class that inherits from it, including Tesla, but it won't make it accessible to a human to change.
How do you set it as protected?
You just, instead of public, that's on screen over there, just write protected. And that's it. Or you can set it to private if you only want the class itself to access that.
Would that work? What if Tesla was inheriting a private method? Would that work?
It won't inherit the private method. It won't be. It will if a car has a private method. Tesla will not inherit that, or won't be able to. It will. I'm not sure, but it won't have access to that member that was set to protect it to private.
Yeah, that shouldn't be possible.
Yeah. All right, I guess we can get started. Are we going to tell the answers?
Oh yes, we could definitely answer that.
All right. So X here will be set to false. Y will be set to true. Z will be set to true. And A will also be true. All right. So let's talk a little bit more now. Let's apply everything that we learned to Unity. Before we do that, let's talk about Visual Studio. Visual Studio is an integrated development environment. It's pretty much like Unity for coding. It has all the tools that you need to code. It has a code editor. It also has a debugger that allows you to debug code. It's used to build code into an executable. In the context of Unity, you don't really do that. Unity does that for you. You can also analyze the code and do some refactoring to it. It gives you intelligent recommendations on how to improve your code. It also allows you to access your version control system, for example, either Git or other different version control systems. I only use Git these days. I don't know what's out there these days. It can do automations, like macros, or for example, you can set a whole block of code to be commented out. Commenting is something we can talk about. But there's a lot of different automations that are included within an integrated development environment. Also, code completion, like I showed you earlier, when you press the dot notation and press dot after the name of an object, you get a list of different members of that class. And also with Visual Studio for Windows, you can get AI assisted code completion too. It's really cool. And the cool thing about Visual Studio is that it is free, and it's on both Windows and Mac, and it's fully featured too. So the different licenses, the enterprise or professional, they don't have any features that are not available in the free version. Also, Visual Studio for Windows and Mac include Visual Studio tools for Unity, and these are specific tools that are designed to make working with Unity much easier. And it's both available for Windows and Mac, like I mentioned. So let's talk a little bit more about debugging. What is debugging? Debugging freezes your code at a certain breakpoint. You can set a line of code and tell the program to stop right there. So you can go check to see what is the value of this variable at this specific moment. And what is the value of this class and what's going on within your code. Like, you can really start digging deep into your code to see what's really happening. That's what debugging is. You can also freeze based on a specific condition. You can say, if X ever got equal to 0 for some reason, if you're playing a game and your character just keeps stuttering, their speed keeps going down to 0 for some reason, you can set it in code to be like, break break the code, stop here, freeze the code, and whenever the speed of this player or character or whatever game object that you have has reached a certain condition, like 0. And so how are the concepts that we just learned applicable to Unity? So classes in Unity are pretty much like all the things like game objects, rigid body, collider, mesh collider, sprite. All of these different components are just classes. If you look at the code for each of these objects, they're classes, and that's it. And there's classes that are members of other classes too. So you can create a transform for a component, for example, is a class that is inside of the game object class. Let's see. Yes. So every or most classes within Unity, the ones that I just mentioned earlier, inherit from a class called monobehavior. Monobehavior, for example, adds a transform to your class. It also does these things or enable these things called Unity messages. Unity messages are methods that Unity calls periodically. For example, when an object first gets enabled, for example, that check mark in the inspector, whenever that's checked, on enable runs, and then start also runs after on enable whenever a monobehavior class runs, and then update will actually run once every time a frame gets drawn on the screen. So if your game is running at 60 frames per second, update will run 60 times in 1 second. And usually when you get dropped frames, it's because something is happening in the update function that is very resource heavy, that is slowing everything down. And then whenever you destroy an object, there's also a method that will run called onDestroy. And you can create these inside of your Unity scripts, and they will run accordingly. Unity will recognize that these exist inside of your code, and will start calling them when it's appropriate. You can also go into the Unity documentation to go see what is the sequence of all the Unity messages. what I mentioned here is just an example of them. Also, a cool thing about monobehavior classes is that if any variable that you create in there that is public will show up in the editor if you assign that script to a certain game object. You'll see in the inspector, you'll see the public variables in there. So let's do some coding. I think this is the fun part. We're actually going to get into Unity. Let me turn on Unity. Of course, it's going to do a thing. Okay, good. So here, this is a simple scene that I created that has 3 different objects, game objects, a human, a car, and a Tesla. Let's recreate that same those same classes that we created earlier in our previous demos. So we can press on car over here, and then we can say add component, and we can say this is a car. So let's just say car. Well, there is no cars that exist within Unity. There's no script that has been created. So we can create a new script, call it a car, then press create and add at the bottom. Let's see, it's thinking again. And let's double click on car. And that should open up Visual Studio, but I already have it open here. All right. So this is the class that it created for us. Created a public class called car, and it inherits from monobehavior. Because it inherits from monobehavior, it will be aware of those Unity messages that we talked about earlier, right? Start, update, and there's other ones too that I'm going to talk about in a bit. So let's create a car. Whoops. Let's create all the variables that we wanted. We created before. I'm just copy pasting the same thing. Public, type float, dimensions. I mean, realistically, you want to put, each one of the dimensions in a different variable. But we're creating the different variables here. And then let's create also the different functions that we have. The order of of methods doesn't matter. You can put update on top of start, and it really doesn't matter. So now I just copy pasted and added lock door, open door, reverse, accelerate, all of these different methods that are associated with the car. Now let's go back to Unity. Where is Unity? Here. And let's look at Tesla. Add component. Let's create a Tesla. New script. Create an add. And that just launched Visual Studio right away. And we can see that there is, if we look at the Visual Studio here and look at the different assets that we have in the Unity Project Explorer, which is part of Visual Studio Tools for Unity, you can see the Tesla C# script. And they're all the C# scripts end with CS, C#. So that's an easy way for you to recognize which ones are C# and which ones are different things. So this is Tesla. Now we created the function, the class, and now let's add the variables and the methods. So I added a variable called battery capacity that is public, and I created a method called charge that takes volts, or integers called volts. And here, just created a method for autopilot. So now, if we go back to Unity and look at the script called car that's been added as a component, we can see that dimensions are available. We can edit them right away in the editor. And max speed, acceleration, seats, doors, all of these different things. You can double click on this and it will highlight it within the project. But what if we don't have this component? This component has been removed from the game object called car. How do you add them? You can either add them from here. You can just say car and it will actually show up, and you can just add the script to it right away. Or you can drag and drop it too. In this way, you can change the different dimensions, like 10, acceleration by 5. This is a very slow Tesla, by the way. It's a 2-seater. Do they make 2-seaters anymore? I don't think so. And 4 doors. And if you're like a Tesla, also same idea. We can only see kind of the public variables in Tesla, not in its parent. Unity does not show that for us, sadly. I don't know. Is there a way to show the members of a thing?
Yeah, if you put serialized field in brackets above it.
Okay.
Yeah, that makes a private thing invisible in the editor, but it does not make it a public thing. So
okay.
No, and you can change the values in the editor too.
Okay, awesome. So yeah, there you go. That's how you do it. So how about we want to also create a human? Like we have a human, we just want to create a script for a human. New script again, create an ad, and human should pop up here. Now we can edit the script for a human. Let's see. I want it so that when, let's see, I'm just trying to find a thing we can do that's pretty cool. Yeah, there you go. I wanted to create a method that takes a Tesla, but then charges a Tesla called T, and then charges it by 45. Or actually, let's not do that. Let's not do any of that. Let's just create a human unlocks cars. And there's a method that we're creating for a human called unlockDoor. And here, a human needs a Tesla. So public Tesla, we're calling it T. There you go.
Did your Tesla inherit from a car? Was the question in chat. I wasn't.
That's a very good catch. There you go. So now I'm having Tesla inherit from mono behavior, but that's not correct. There you go. That's the correct way to do it. Good catch. But now, because we're inheriting from car, and car also inherent from mono behavior, that makes anything in Tesla, make anything in mono behavior also accessible to Tesla. That's fantastic. So now here we can say T dot unlock. As you can see, it gives us, or I think it's open doors. I think that's what I created. Yeah. An open door is available in car. It's not available in Tesla, but we can still access it from the Tesla object here. So let's try to run this. What's happening? Let's see. Yes, here. I want it so that every time a human starts existing to unlock the doors. So I'm just going to call the method at the bottom called unlock door. This one is highlighted here. And the cool thing about Visual Studio, it highlights it for you. So now when we run Visual Studio or run the game from Unity in the editor, we're getting an error that says object reference not set to an instance of an object. That is because if you look at the code here, we just created an empty shell of a Tesla. We never really filled it with anything. But I want this Tesla to be this Tesla in the game, in our hierarchy, in the scene. The way that you can do that is very cool. And this is kind of one of my favorite things to do within Unity, is that if we go to the human script and we can see that there is a public Tesla, but it's empty. This is just an empty shell. But you can drag and drop this Tesla and put it here. And what this does is that Unity will look inside of the Tesla game object, and it will look for the script called Tesla within that game object, and it will assign it to T over here. So now Tesla is not empty, or the T in Tesla is not empty. It's filled with the Tesla in the scene that we created over here. So now if we run this, it won't give us that error, and instead it will unlock the door. But let's do some checks here. Inside of the Tesla, or in the car, actually, in the car class, we can do a check here. I want to see if we're actually reaching this code here inside of car. The way to do that is to use the debug statement with or the debug class in Unity. You can say debug.log. And I don't know if you've noticed, but if you press dot and you see these starred suggestions, these are AI-powered suggestions. And it will look through all of the code that people have made for Unity, and it will see the most common things, and it will suggest the most common things. There's so much to talk about. If I want to dive into IntelliCode, AI-assisted IntelliSense, it's going to be a whole session. But yeah, so debug.log, and anything we write here is going to be printed inside of Unity, and I'll show you where now. So here we can say doors open. Just a little message. And now when we go back to Unity and press play, here it is. In the console in Unity, we saw what we printed using debug.log. So this is cool now. So what happened is a human got the Tesla inside of the game scene over here. The Tesla inherited from car and then executed the open door method and then printed doors open. So you can see how everything kind of worked together that way. So what if this wasn't working? What if we weren't getting this happening? We're just not getting that printed at all. So how do we stop the code here? I want to see if the code is actually getting here or not. So what you can do is that you can go all the way to the margin to the left here and click. And that will create what we call a breakpoint. And then if you look up here, it says attached to Unity. What we want to do now is attach Visual Studio to Unity so that Visual Studio is aware of the code being executed inside of Unity. And if you have different unities, like instances happening, you can find like the different ones up here. But we can just say attach to Unity. What this will do is activate the debugger. And now it's all ready. If you look down to the left, it should say ready. You can go back, enable debugging for this session. Yes, please. And if we press play, is it still playing? Or is I need to re-enable the debugger? Stop this, attach to Unity again. There you go. And now when we press play, it actually stopped. It stopped Unity. Unity is frozen right now. You can't really mess around with Unity because the code just kind of froze. And now we can see here what's going on with our code. We can hover over different parts and it will tell us dimensions are 0 because we set them up in the editor as 0. Max speed is 0. Acceleration is 0. Seats is 0. But then here we can look into more of the hierarchy of what's happening here. Oh, wait, we're in car. But yeah, anyways, you can take a look into the code and see every single class that you have, every single method, every single variable that they have, and really dig into what's happening in your program and what's causing all of this to happen. And that's what debugging is. And it's very powerful. And once you start getting to know how to really utilize it, especially when projects become way too big and you start facing unpredictable kind of behavior, you can really, it can really save you a lot of time by just freezing your code and taking a look at it and making sure that things are operating correctly. You can press on it again, and that will take away the breakpoint or leave it. And here, if you look at the top, you can either stop the debugger by pressing the stop sign. And then there is continue. You can continue to the next line. You can step into. If there's a method there, you want to trace the method and go deeper into the rabbit hole of code, you can dive into it. If you want to step over it and just step to the next line, you can press step over. So there's multiple different things you can do once you froze the code here. Or you can just press continue and that will continue your code. And yeah, there you go. The code continued and Unity is operational again. So that's debugging. One of the last things I want to talk about is things like if, let's compare tags, for example. I want to compare different objects with a certain tag. So let's say this game object dot tag. This is kind of an advanced topic, but wait, is there a game object dot tag should be here, right? Or name. Yeah, there you go. Tag equals to player. You know, sometimes you want to do that when collisions happen or anything like that. And just do a certain operations like debug.log, whatever. When you do something like that, an operation like that, sometimes you'll see this little light bulb pop up. And that's the analyzer. The analyzer looked at your code and said, hey, don't use tag equal, because that's very inefficient. If you do that within Unity, comparing a tag with a string with a string is actually a very expensive operation. And instead, Unity has created a function called compare tag, or a method that you can use. and use that instead, because that's much more efficient. And you can just say, use compare tag method, and that will replace the code that you've written with something a lot better, and will have less of an impact on your performance. There's a lot of different, let's say, analyzers within Visual Studio. We have open sourced these analyzers, so you can look at our GitHub repo and look at all the analyzers that we have created. Also, if you look at here, also the red line, the green and yellow, this just tells you the impact on performance. Before, when it was tag, it was red, because that was a heavy, has heavy impact on the performance. So that's that's the power of Visual Studio. It really gives you all of these tools and for free completely. So whenever you see that light bulb, highly encouraged to look at it and read and see if if that's something you want to do or not. And if you want, it will automatically do that for you. So let me just check if I covered anything for today.
We did have a question from the audience of what does tag do? And that's something that you can't really explain without showing it, I think.
Sure, I definitely would love showing that. So the cool thing about Unity 2 is that you can give any of these game objects a tag. If you click on an object, go to an inspector, and you'll see here, up here, it says tag. Under its name, if you press on it, these are tags that are available to you, but you can create add tag. And you can press the plus sign, and you can create a tag called player, for example. Save. And now, if I go back to the object, I will find that player got added to the list. And it's just a way to tag things. It's really like a post-it. You know, you're just putting it, and it's an identifier, and that's it. So you can access it from code, like I just mentioned. You can say if there's a collision happening, and then you only want a certain operation to happen if that if a player or an object with the tag player is interacting with this, then do that. Maybe, for example, if an enemy interacted with other enemies, it doesn't really do anything. But if it interacted with a player, then the player takes damage. So you do that type of check, and you say if the tag, this tag is compared. Let's go back to the code. You can say this: if game object compare tag is equal to player, then do damage, for example. So that's kind of why or how tags are useful, really. Another thing that I want to talk about really quickly is commenting. Sometimes you want to write things inside of the code here that is not executed. You just want to add notes or something like that, or just have this line of code not be executed. You can put / in front of any line, and that will make all the line commented out. And that will not be executed by the runtime. You can also comment big chunks of things by putting /*, and that will comment everything down until you put */. And now all of this part in green is not going to be executed by the code. It's going to be out. But it's good sometimes to have it in there. You know, I don't know why you want to have in there, but sometimes you want to like test out different things that you're doing, and you comment some parts out, and then you comment them back in and see how different does your software operate. But also, it's really nice to leave notes to other people who are using your code by saying this method I can't type today, will open a car door. This will not be executed at all, but it's a good note to leave to your fellow programmers, but as well to yourself sometimes. Nothing is worse than going back to your code after a couple of weeks or months and not knowing what the hell you've done there. So yeah. So I guess that really concludes my my talk today. I think we talked about different classes and how they operate inside of Unity. We talked about public variables and how if they are public, then you can just edit them directly within we can just edit them directly within the editor. We talked about debugging. We talked about the analyzer and talked about debug.log, which will be your best friend. And yeah, if you look at all of these here, like all the different components, like transform, cylinder, mesh renderer, all of these are scripts, are C# scripts. They're mono behaviors inside of them. And when you're creating new scripts, new mono behaviors, what you're creating is it's a new component, pretty much. So yeah, I hope that covered all the topics that you wanted to hear today. Right now I'm open for questions. Oh, yes. Here's all the resources that I've used today. I have links to all the tutorials, as well as a lot of different videos. There, if you want to download Visual Studio, you can go to visualstudio.microsoft.com. And there is also in the .NET website, there is a new Learn portal that is, I'm going to link it inside of this link, that has a whole bunch of different video tutorials, especially from the ones from Brackeys are amazing. Sadly, he stopped making videos recently, and that was very sad for the community. But he has different sets of different videos for beginners, intermediate, and advanced developers. I highly encourage those videos. Encourage you to watch those videos. And there's also my contact information is on the same link. So if you want to contact me on Twitter or email, please feel free to do so. Yeah, thank you very much. And I'm open for questions.
Okay, thank you very much. I'm going to have to ask you, could you, Abdullah, could you post that URL into the Twitch chat for us, please? Or send it to me in Slack. I tried to type it in myself, but of course it auto-expands, and I don't want to paste in the auto-expanded version. I wanted to paste in the short version, and I am wrangling two machines.
All right, I'm going to try to open up
text editor. Oh, you can post it in the Zoom chat, and I can copy from there.
Oh, the Zoom chat. Okay.
Yeah,
sure.
that'll do it. Thank you. Just need
an
extra pair of hands sometimes with all of these buttons.
How can I open up the chat? Oh yeah, right on the top there.
There you
go. AKA.ms, that is Microsoft's shortening service to shorten links. And then C# for Unity.
There you go. All right. Yes, please do fire up your questions in chat. We've had the first one in so far. Boss Runner. Is there some advantage of C# over C++? Is there a reason why Unity chose C#?
So one of the things that I didn't talk about today is memory management. In C# or C++, and C before that, when you created a variable or created a class or like anything that's inside of memory, like we said, we used a new operator and filled up the memory, you need to delete that or else the memory will get used infinitely until your computer crashes because there's no more memory. You need to manage that memory yourself in C++. In managed, what we call managed languages like C#, there is a thing called the garbage collector that keeps track of all the different variables that you created, all the classes, instances, objects that you created inside of memory, and will try to purge those and delete those every now and then. Of course, with that becomes unpredictability. Sometimes the garbage collector will kick in, while you're in mid gameplay and cause some slowdowns. So if you're not aware and just not aware of your memory usage when you're programming in C#, those slowdowns can happen. So that's kind of like one of the differences. As C++, we also mentioned C++. When you're developing in C++, if you're developing something from scratch, let's say, in C++, without a framework, without a game engine, then you really can't run an application on all of these different machines and different operating systems without modifying that software to run on those machines. C# runs on a runtime. Anywhere there's a runtime, there is a car, somebody can get inside of that car and drive it. So if you write C# code, it will run on, PC, Mac, Linux, and iOS and Android and all of those different platforms, unless you're using, platform specific things, but like cameras or something like that. But your C# code will run everywhere, and that's kind of what's so cool about it. Its syntax and how it's written is very simple, not that confusing, and it focuses really on simplicity, offering powerful resources for you, but to keep it simple. When C++, I feel personally, we go into like tribal rivalries at this point, but I think that C++ is designed for performance over everything else, where I think C# tries to be a lot more approachable for people. C# runs on a browser right now, so that's great.
Well, yes. You just demonstrated that today. The fact that you have pretty much a whole IDE in the browser now, which is
pretty
very
much
cool. Yeah. Nice work there, Microsoft. There's a good question actually here from Peter, and I wondered if you could clarify it. So you can have var in your code. So it could be, say, word equals hello in quotes, or it could be var number equals 3. So we can use the word var as a shortcut to declaring what type a variable is. Is there an advantage to using var instead of, say, int, float, string? When would you use var over being explicit?
It's just about simplicity. It's about getting things done really quickly, and you just want to hack something really quickly and for it to happen. Or if you're getting data that you don't know its type and you just want Unity or .NET to kind of figure it out, it's using var might be a good idea. But I think if you want to focus more on performance, because var, the operation to kind of figure out what type it is an expensive operation. And if you can eliminate that from your code, that's great. And so using just explicit types, then you're gaining some performance there. It's pretty small when you're looking at like smaller games, but if you're building huge applications, especially if you're using the cloud where like millions of people might be using your application, and if you're shaving off milliseconds from your application, then you might save up a lot of money. So things like that, right? Like you're getting more performance with using explicit types, but you're getting flexibility and ease of use by using var.
That's a good question.
Cool.
Yeah, thank you.
Someone asked, is there an advantage? Oh, wait a minute. Where is it? What's the difference between Visual Studio and VS Code?
VS Code is a code editor and not an IDE. An IDE comes with all of these different features. Like I said, the automations. Let's go back here. It comes with, code editor, code completion, debugging, building tools, analyzers, version control things. All of these things are integrated within Visual Studio and come ready out of the box. Visual Studio is not open source, but Visual Studio Code is an open source code editor. All it got is the code editing software and maybe some code completion, but all the other parts you have to like kind of put together yourself and install the different components the way you want. It is very powerful and very flexible. But also the VS Code Unity plugin that you can install to make it work with Unity is not developed by Microsoft, and it's developed by Unity instead. And in Visual Studio tools for Unity, in Visual Studio and Visual Studio for Mac, we actually put a lot of effort into creating a great programming experience, a great debugger, and analyzers, for example, are not available in VS Code. All of these different features that we have in Visual Studio tools for Unity are not available for Visual Studio Code. So it's really just preference. Do you want something that has everything ready for you to use? Or do you want to kind of mix and match your own and kind of build it from scratch almost?
You can never have too many editors.
I know. I have all of them.
One of my favorite things with VS Code is, because I do a lot of web development as well, and if I work on a web service that I need to talk to from a Unity application, for example, I might do it in Node, and I can run a terminal window inside of the same window on my VS Code, and so I can do all of the server-side debugging on this little VS Code instance, and there's my full VS on the left-hand side, which has got all my Unity code in it, and it kind of gives me a nice separation, a brain separation between what I'm working with in Unity and what I'm working with elsewhere. And both tools are good. Both tools are great.
And right now, too, if you go to Visual Studio Code runs on a browser, too. So what we saw right now in the browser was actually a form of Visual Studio Code, or parts of Visual Studio Code powering that. And yeah, I mean, in GitHub, too, you can, I think it's available right now, or we talked about it earlier, we can just edit code in GitHub powered by kind of Visual Studio Code. So yeah.
That's crazy.
Visual Studio Code is like the lean, flexible kind of younger sibling of Visual Studio.
From those of us that came from the, I just want to use Notepad generation.
Exactly.
we started off being belligerent and saying, I just use Notepad. And then it got better.
Actually, the debugger in Visual Studio and Visual Studio for Mac is amazing, and that's kind of why I still use Visual Studio and Visual Studio for Mac when developing for Unity. And the refactoring, those analyzers really helped me out. I figured out things that I was doing with my code that were horrible and really affected the performance, and it just told me about them.
We're coming up to 9 o'clock. Does anybody else have any questions you'd like to ask?
Peter did ask, when is part 2 of this? Probably not tonight.
Should there be part 2?
Well, I mean, that's a good question. So, what would I'd like the audience to tell us? What would you like to learn about next? It's if you have requests for specific topics, you can always ask us. We are open to requests. We'd like to know what it is you're interested in learning about too.
Just tweet at me, email me. Even if you want something that is not related to Unity, email us. If you want to know how to create a mobile application for your game somehow, or you want to learn how to use Azure PlayFab, that it's a cloud service for game development, and for your cloud services and whatnot. They have a plugin for Unity. If you want to learn more about that, I can talk about that. So there are so many different ways that I can introduce or can share information with you.
Awesome.
Yeah.
I don't think we have any more questions right now. Any more questions? Last call for questions. I guess now they'd have to type the question, and it takes some time. Type faster. No more questions.
Also, please, if there's some parts of it that you think I can improve on this talk, if you think that I should dive into some different parts and spend more time there, let me know. I hope to deliver this talk to other folks that will benefit from your feedback. So,
excellent. Well, thank you very much. This has been a fantastic talk. We've had a great audience as well, middle school and up. This has been fantastic. Thank you. we will. Well, I think we should wrap it up. Really. We will be back next month for what month is it next month? October.
October, yeah.
Yeah, it's October next month. We are hoping to have a Lightning Talks month. At the moment, we haven't yet firmed that up, but that could happen. If anybody in the audience has a topic that they would love to tell somebody about, but doesn't think they can spend too long talking about it, or maybe they just want to burst out some information over a 10-minute blast, we would love to have you on the show. Please message us. We will be on hang on a second, what am I doing here? Gallery view, there we go. Yeah, we're on Twitter. You can contact us via Meetup, and we'll get in touch. Otherwise, thank you very much again, Abdullah, and we'll see you next month.
Yeah, thank you very much for having me.
Yeah, thanks a lot.
All right,
and again, we'll post this online.
We will. Yes. No, this video recording of this session will be available for, I think, 2 weeks on our Twitch channel, and we will post this on our YouTube. I promise.
Great.
Hereby promise to post this on our YouTube.
So thank you.
Thanks, everybody.
All right. Thank you very much. Bye.
Bye.